Hello, what's up everybody? Today, um, I'm going to be showing you guys this debugging programs thing. I didn't know it was going to be this short, so I said in the title that it's going to be debugging programs and looping, because looping is the next thing, so decided to add on to that, not just make it like a 10-minute stream. That would not be good for the viewers who are watching right now. I'm also eating a little bit right now, so yeah. Let's watch this video, and then we'll get to the document.
Now that your programs are getting more interesting with functions and logic and all of that, you'll likely find yourself introducing more mistakes into your programs. And it'll bug you when those mistakes keep your program from doing what you want them to do. You might instantly know what's wrong, but sometimes you have to spend some time debugging. And I want to give you some tips for doing that in this talk through. I've started with this program that has a white rectangle in the middle and instructions to click inside of it. When I click inside, I expect a rectangle to show up where my mouse was. But right now, it doesn't work. And if you want, you can pause right now and verify that that's true, that it's just not working wherever I click. All right, so why isn't it working? Well, let's debug it together. The first thing that I'm going to check is whether the mouse clicked function is being called at all. It should be called every time I click the mouse, but let's just check and make sure. An easy way to confirm that is to stick a print line right inside the function at the top. Clicked. All right, so now when I clicked, I see the console pop up and it says clicked. All right, so we know that mouse clicked is being called like we expected. This print line function here is a handy way to debug your program. And when you're done debugging, you can always remove the statements by deleting or commenting out and close the console. Okay, the next thing I'm going to do is check to see if this code is ever reached here inside the if statement. Because what I'm really trying to figure out is whether this is ever true. So I'm going to put another print line inside the if. Woo! And you might say like, oh, well, there's a rect here. We would have seen the rect. But sometimes there could be a problem with what we're showing. There's never going to be a problem with doing a print line. So print line is a way to make sure that some code is getting called. All right, so now I'm going to try clicking again. Okay. I'm not seeing anything pop up in the console. All right, so that means that the thing that's wrong is that this is never true. So I have to figure out what is wrong with the condition in the if. Why is it never true? So to debug if and conditions, I often start with just printing out the values that I'm checking to make sure that they're what I expect. All right, let's see, click around. Yeah, so all of these values look really reasonable to me. So now I'm going to print out the conditions inside the if. So I'll take this first half here, and then I'll take the second half. And this just helps me narrow it down since this is a complex condition. All right. So what I'm seeing is that the first condition is true and the second one is false when I expect it to be true because I'm clicking in the corner of the rectangle. So now I'm just gonna read through the condition and see. So mouse y greater than 100. So mouse y greater than 100. 100 is the left side of the rectangle and the top side of the rectangle. So for y, that makes sense that it should be 100. And then we have mouse y is greater than 400. Okay, well that's wrong because when mouse y is inside the rectangle, it's never going to be greater than 400. That would be outside the canvas. So what we really should be checking is that mouse y is greater than the top of the rectangle, and mouse Y is less than the bottom of the rectangle. And the bottom of the rectangle would be 100 plus 150, 250. And now we can see true, and so I'm going to go and change my condition here. And yay, rectangles. Okay, so now I'm going to keep clicking, and I see that I can't get rectangles in the right side of the rectangle. So there's still something wrong with this first condition here. So let's read through this. So mouse X is greater than 100. That's right, because 100 is the left side of the rectangle. And then mouse X less than 150. Okay, so this is the problem here. 150, that only gives 50 pixels where this condition is true, but it should actually be true for 150 pixels because that's how wide the rectangle is. So this should be 100 plus 150, 250. Now we'll see it's true. I'm going to go and change this inside the if. And let's see. Woohoo! Rectangles everywhere we click. All right. So it looks like I've fixed everything. And I'm just going to, check and keep clicking around, seeing if I missed any edge cases. See that, everything is working as expected. Great. Now, you may have figured out what was wrong with my code before I did all of this print lines. But you'll probably run into code that's trickier than this. And you can use the same techniques for it. You just figure out which of your code is actually being run, and then figure out why it's not being run, or why it's being run in a weird way by inspecting the values and conditions. And you can use println to do that really easily.
Okay, so that was a neat way of showing how to debug the pronouns. Now, this is just more debugging tips. So as we showed, answer the pronouns, blah blah blah. Rubber duck debugging. Sit a rubber duck on next to your computer or whatever duck-like object you have handy, and explain your program and problem to it line by line. Many programs find that just the process of putting the problem in words helping their brains realize what's wrong. You can also ask a friend or teacher to be rubber duck, sitting and listening to you explain it. Sometimes they might even think of a solution for you, but regardless, they're doing a service by just listening to the explanation. Here's the cool thing: we have to do a rubber duck in the Khan Academy office. It's the oh no guy, literally the oh no person. It's funny. Okay, exaggerate your out point. Um, so just read over that stuff, and it says hard to see. Can you see it? Point 30-30. Make it obvious with a big stroke. 30. What a stroke weight 30, and then point 10-10. And then that's all for the more debugging tips. Then there's more comments down here and stuff. Not going to go through those at all. Next is looping, which this looks like a ton of stuff. I mean, it's a video, a practice, a challenge, a video, challenge, video, challenge, video, review, project. So let's just look through this. I'm probably going to be able to. I'm not sure if I'm going to be able to get it done today. I'm probably going to just get this one done today, and that's it. Because the next lesson is writing clean code, which let me look. Okay, it's just three. It's just two videos and another practice. So I'm gonna go back to the loops, which I don't know why it's not showing for like the full thing. Intro to while loops. Okay, I'm going to mute my mic. Like everything that we do, I never done. I never viewed any of this until now. So I'm not going to play the video yet because I have to do one or two things real quick. This may be an hour, but well, I mean, this stream may be like an hour or two, but I don't care. This might take 10 to 15 minutes. I'll be back. Okay, guys, I'm back. Sorry it took a while, but okay. So intro to while loops. Let's watch the video and learn from it.
Let's talk about loops. So I have a while loop here, and with just a few lines of code, I can write this message all the way down the screen. If I go ahead and change the message like this, to make it better, all of them change. So how is this working? Well, we can revisit this code in a moment. But first, let's take a step back and think about how we might write this program using only what we know so far without using loops. So to do that, we're really just going to write a bunch of text over and over and over again, right? We're going to say text, message, and put it in the first place. And now it's just a matter of repeating this enough times so that eventually we get all the way to the bottom. And that's going to take a lot of work, right? Because the bottom is really far away. And it's even worse if you then point out to me, hey, this wasn't actually 70, it needs to be closer, it needs to be at like 60. And now that affects this one because it also needs to be smaller and all the way on, the more clumps of text we have. And in fact, this way it's going to take even longer to get to the bottom. So this is really a pain, and thankfully we have loops to help us. From now on, anytime you see repetitive code like this, your first thought should be, could I use a loop? A loop will let us repeat this piece of code over and over and over again, making just little changes each time. So here's how we would rewrite this code with a loop. To get started, we need to type while, the parentheses, and the curly braces. We're going to get this message, but it's just because we're not done yet. Don't worry, it'll go away when we finish. So every time you write a loop, you need to answer 3 key questions. And here they are. So the first question is, what do I want to repeat? And whatever we want to repeat needs to go in between these curlies. So we want to repeat the text call in this case. So I'll go ahead and put that in here. But it's a little bit silly, right? Because right now we're just going to be repeating the same call to text over and over, which is not really any good, right? We need something to be changing. That brings us to question 2, which is what do I want to change each time? So we want to change this y position, right? We want it to become 60 and then we want it to become 80. So we'll make that into a variable instead, called y because it's the y position. And we'll go ahead and declare a variable up here. I'll start it at 40. And now, finally, we just need to be changing y. We can do that down here. We can say y gets y plus 20. And it'll be getting bigger every time. In fact, we can use our lesson from incrementing shortcuts here. We can just go ahead and use the shortcut. So this is fantastic, and we only need to do question 3 now, which is how long should we be repeating this? Well, we want to do this over and over and over again, but we don't really want to do it forever, right? If we do it forever, first, that's a really long time to wait, and second, it might even crash your browser, but hopefully not. So really, we only want to do this until we get to the bottom of the page, right? Which means we want to do it as long as y is less than 400. So we can just put that in here, and there we have it. We have this message being written all the way down the screen. And you can see that this is way simpler than our previous approach, which took about as long to write, but we weren't even a quarter of the way finished. So we can get rid of that, and there we have our program. Now, let's try to get a better understanding of what's going on. To do that, I'm going to print out y each time. I'm going to say y is now. And then down here, I'll just tack y onto the end of the message so we can see it. So at the moment, the value is changing by 20, right? And we can change that just by changing this variable here. We can make it, like 50. And now we have it changing by 50. Similarly, you can go ahead and play with these other values and have them change. And you can see how that affects, where the program stops. So to understand this, you can think of it sort of like an if statement, actually. We have our Boolean expression in here, just like you learned. And then we do the body of the statement, this part, only if the Boolean is true, and otherwise we just jump to the end. But what's interesting is that with a while loop, we actually have this secret thing going on at the bottom, which says, go back to the start of the loop. And what this secret instruction means is that instead of leaving and just keeping on going, like with an if statement, every time we do the loop body, we're going to go back and check if the condition is still true. If it is, we're just going to repeat one more time. And just like you might have guessed, the second time we repeat, we're going to do the same thing. We're going to check, hey, go back to the start. Is y still less than, 279? And if it is, we'll repeat one more time and keep checking. And if it's not, we go back to the start here. Then finally, we'll get to escape, and we'll get to keep going with our program. So great. There are a lot more interesting ways of using loops we're going to learn about soon. but for now, you're off to an excellent start.
Okay, so we um, did the intro. Now we're going to do a practice, which it's 6 problems. A practice means um, it it basically means multiple choice, like a multiple choice review of the last thing that we did, which was we watched a video on loops. So yeah, it's like solve like var I equals 0 while I is 3, and then print in high, and then I plus plus, and then what does the code output? This was in the the debugging video. Well, I no this no I mean the print in thing is the debugging thing. The code output for that. Let's actually copy that, and then let's go to JavaScript code. Let's just say, JS Fiddle code program. Now let's paste that stuff, and it shows nothing. Like it says purge no library. Let's see. Let's just do whatever. This. Okay, I'm not gonna mess with that stuff. So that's like a example not to do. But I did forget to tell you guys this. So in the description of this video, I put I put this link in here, which is Intro to JS, Intro to HTML, SQL, Advanced JS, all these mini like little lessons. It's the course which is called computer programming. If you want to know more about like the computer programming and code like that. I'm doing the intro to JS right now. I'm working on the looping, and then there's writing clean code, then there's arrays, objects, object-oriented design, and then becoming a better programmer, which I like that I only have like 6 topics left, but there's still a lot to cover. So I'm probably going to still be doing this. But let's get back to the matter at hand. So do you think it'll be that high? Wait, no, I think it'll be this high because, right? Yep, that's high. Okay, so note, the printin function prints out a line of text with a value that you pass it to it. So if you say printin high, the output high. That's like the last thing that we did. So consider the following code. So printed high and then printed by. Which one will it do? Will it do hi by because they just did the 3, or it'll be hi by. I mean, I think it'll be hi by, but yeah, I think it'll be that. Nope. Let's see this one right here, yeah. Really? Wait, C? How is it C? But you improved your answer. You gotta keep up with the great persistence. Which I always want this to be 100%, or else like it'll not show a check mark or anything. So using while loops. Okay, so consider the following thing. So print in high. So it will output an error. It won't output anything. It will only output this line, which is high. So I think it's this one. Nope, it's either an output error or it won't output anything. I think it won't because it's a 0. Yep. Okay, so consider the following code, all that stuff. Print in X. What does the code output? So X equals 3. It's 3, but it says Y. I mean that 3 X plus equals 1. I plus equals 1. I think it's gonna be this, but I hope no. Let's get a little help. Let's see. So once the program prints out, wait, is this all? Wait, no. Once the program prints out the value of X after the loop has executed 3 times, the value is now 6. So 6 would be that. Would be your. Okay. So what code does this output? So 3, 4, 5, 6, 1, 2, 3, or 3, 4, 5. So consider the following code. Var I equals 3, while I that's 6. Print in I plus equals 1. So I think it's 3, 4, 5, 6. I think it's that. I hope. No. This one. Okay, yeah. Yeah, it's that one. Okay. What does this code output? Let's see. Var IO. I think it's. I want to say it's 0, 1, 2, 3, but I'm thinking it might be wrong. I'm just going to check it. Yeah, I knew it. 1, 2, 3. Wait, what? 1, 2, 3, check again. 0, 1, 2? How? So show summary. Summary is 1 out of 6. That's bad, but I mean it's not bad. It's like okay, let's keep on doing this. So it's hi or hi. So it'll be hi. Okay, hi bye. I think it's wait. Yep, hi bye. Oh wait, hi bye. Okay. and then it won't output anything because of the 0. Okay, 3 more. Okay, so it'll be 6. I mean, they give you the same exact answers. I mean, like the same, not the same exact answers, but the same exact like problems, so it doesn't keep randomizing stuff. So 1, 2, 3 is what they did. Nope, that's not what it did. I think they did 3, 4, 5, right? Yep, 3, 4, 5. Okay. Code output, 0, 1, 2. I think that's what the okay, 4 out of 6. 408 energy points. Let's keep on going till we have good. So hi, boom. Hi, bye. Air, not air. Out. Won't do anything. Won't do anything. Okay. So 6 would be this answer. So you got it. Onward. Okay. So it'll say 3, 4, 5, right? Okay, and then this one would be 0, 1, 2, right? Wait, no. 1, 2, 3. 0, 1, 2, right? Okay, 0, 1, 2. So that practice is a 5 out of 6. I'm gonna just try this one more time. Let's do the hi. Bye. Won't output anything. 6. It would be 1, 2, 3, right? 3, 4, 5, right? It's 0, 1, 2. 5 out of 6. Try to beat your score. I'm gonna try. I want to get 100 on this, so I'm gonna keep on doing it till I get it, which will probably be this time. Bye. Won't output anything. 6. Yeah, I finally got 100%. I don't know why, but it doesn't say checkmark, but it does matter. So challenge, a loopy roller. Let's see how we repeat the text command multiple times to draw rule markers for the x coordinates along the top. You'll replace that with a loop, with a while loop that does the same exact thing. So you'll remember to think about what do you want to repeat each time, what value do you want to change each time, and when do you want to stop looping. So var something, wait, var something equals, and then while that text that 10, and then that plus equals, so x plus 150, x plus 150, that's 0, so it's like 150, that's it, and then that plus equals, okay, so that's gonna be that, and then the video challenge, video review project. Write clean code. Okay, this will be smart. I'm gonna mute my mic so you won't have to hear me anymore if you don't want to.
Now that you've learned the basics of loops, let's go ahead and walk through making an awesome loop drawing, like this one, balloon hopper floating through a beautiful sky. As I go through writing the program from scratch, I want you to think to yourself about how you might do it on your own, because pretty soon you will be. So first, it always helps to break down your program into steps. We'll start by drawing these balloons, which are just the same ellipse repeated over and over and over, and that sounds like a job for a loop. Then, we'll take on these lines, and then finally, we'll add Balloon Hopper herself. Alright, so here's a blank slate, which can be pretty intimidating. Sometimes it helps to make things just a little bit more friendly by adding a background right away, just to get into the swing of things. Now, since we want to draw a loop, your first thought should be those loop questions that we covered last time. And we'll go through them pretty quickly this time, so if you need a review, just revisit Intro to While Loops. Now, the first question, what do we want to repeat? So let's try drawing that first balloon, because we want to be repeating those balloons. You can go ahead and do that, maybe like that. And, well, that's kind of small, it's not quite in the right place, so let's just try moving it a little bit. And this is just part of programming where you try something, you realize it's not what you wanted, and then you try again, and eventually you get closer and closer. Okay. Now, we need to color it probably, right? So we didn't think of that when we were thinking about the steps. We can just say that's just part of drawing the balloon. Alright? And next, we need to think about how exactly we want to be changing this balloon during our loop. Well, we want the balloon to be drawn across the screen, right? We want it to be drawn like here, and then here, and then here. So we want the computer to do it, because my drawing's really bad. So we can fake that a little bit, just by changing this first number, which as you remember controls the X position, the position sideways. But, that's pretty lame, right? That's not really like that cool picture we had before. So instead, let's say that we're going to call this X for the X position, and we're going to make a variable that's about what it was before. And now, we're going to be changing that variable inside of our loop. So we'll use a while loop, and then inside that loop, we'll say that X is going to change each time, maybe by, say, 20. If we just move that ellipse inside, being very careful, of course, not to move that variable declaration inside, because then, well, just think about what would go wrong. That's actually worth trying on your own, if you're curious. Okay, well, so now our third loop question is how long do we want to repeat? So we can think that maybe we want to just keep going until we're basically run off the side of the screen. So maybe all the way until X is less than like 400. So now this is cool because something's happening, right? But it's not really quite what we envisioned. So just like before, we just have to go through it and just slowly improve it to get it to where we imagined. So first, the ellipses are really squished together, so let's fix that. Okay, so that's good to give them a little bit of breathing room. But, maybe they're still going a little bit too far off the side of the screen, so if we change the ending point, we can start disappearing the ellipses that appear, here, because we're saying, as soon as X gets to like here maybe, stop drawing. And that's what this part of the while loop says. Okay, and we can also say, well, maybe we want to change the ellipses a little bit. Maybe we want to move them all down. Maybe we want to, change their size a little bit again. And the nice thing about the while loop is we can do all of them all at the same time. Alright, so perfect. Well, now looking at these balloons, it would be nice to put strings on them. If we like them, then we need to put strings on them, otherwise they're going to float away. So we need a line for each one. And we think that we want to put that line starting at about the center of each of those balloons, just to make it easy, and all coming down to kind of about the same point. Maybe like that. So how can we make the program do that instead of having me draw it? So we can think that if we want to be repeating something, we would definitely want to put inside this while loop. So let's go ahead and make that line. If we want it to be at that center of the ellipse, well then we need to have it start at these two coordinates. So we can do that, and we can say, well, let's just have it end, kind of wherever. And that was actually pretty close. But again, it's not perfect. You might sense a theme. So we need to fix it. So first let's fix this ugly thing, which is that the string that we drew is actually overlapping with our balloon, which isn't right at all. We really want that ellipse to be covering the line, which we can do just by changing that ordering. You can kind of see a lot of things you've learned are probably coming together here. Alright, so this is good, but maybe we want to change the color of those lines. And how do we do that if we were really making this program on our own? Well, we'd go and look at the documentation, or we'd watch the documentation video if we didn't know how to do that. So we can go ahead and use stroke to set the color of those lines. And maybe make them like, I don't know, maybe like that color. And it's beautiful. Now, last, all we need to do is draw a hopper. And that just requires putting her in as an image, like this. And you can see the documentation for how I figured that out. And just moving her around so that, she's kind of holding those balloons like that and floating through the sky. And there you have it. We're done. You can try decorating the balloons. You can think about maybe adding things to this loop to make those balloons a little bit cooler. And you can even use a loop in your next drawing.
Okay, so we finished the video. Now let's do the challenge. Loopy landscape. What's this? So image, grass, and tree. I mean, it's like my first time with images, but I'll try my best. Okay, we finished that challenge. Now let's go on to this. I might have to leave in about like 30 or so minutes.
Now that you know about while loops, let's talk about another kind of loop, for loops. Here's a for loop I made to praise the most delicious kind of pizza, pineapple pizza. You might think, I liked while loops, why should I care about this new kind of loop? Well, soon you'll see that a for loop is a way to write simple kinds of while loops in a bit of a shorter way. So before we inspect this for loop, let's go ahead and look at a while loop which will be a little bit more familiar, and we'll get back to this for loop in a moment. So, just like you saw in Intro to while loops, we start out with this variable y, and we write a message using that location y. We say that we want to keep going as long as y is less than 300, and change y by 40 each time. Now, just to reinforce each of these, which again should be pretty much review, we can say that, well, pineapple pizza is the best. It's a really important message, so we probably want to be writing it more. So it should probably start higher, so we change that. It should probably go on for longer, so we'll make that bigger. And it should probably be closer spaced together, don't you think? So that's a little bit better. Now let's see how we can change this while loop into a for loop. So I'm going to comment out this while loop just so you can see that a for loop really is doing what I'm saying it's going to do. And we'll say that we're going to create a for loop, and we'll just create some space for us to fill in later. Something really important, kind of different for a for loop, is that it's not just one thing that goes in here, it's actually 3 things. And we tell the computer that by putting these semicolons to separate the 3 parts. So we'll have one part here, one part here, one part here, and then the inside of the loop just like we had before. So what goes in each of these parts? We can think of it as, we can say for, we can say that we're going to have some sort of a start or initialization, then we'll have the semicolon, and then we're going to have some sort of instructions of how long to repeat, and then we're going to have some sort of change happening. So how does that correspond with this while loop? Well, really concretely, we can say that the start sets up this variable y here, so let's copy and paste that over to this first part of the for loop, and similarly it appears first, so it's first. We can say that this middle part is telling us how long we should keep going for, and that goes in the middle. And then we say that the change happens at the end here, so we'll put that at the end of our for loop. And these 3 parts always have to occur in this order. In your for loop, you always have to start out by saying this is where this variable should start out as, here it's 27. Then you need to say how long you want to keep going for, so repeat as long as it's less than 354. And then you need to put how you're going to be changing things. So here we're going to be changing by increasing y by 24. Then, last, you just have to do whatever you wanted to do inside the for loop. So we'll go ahead and write that text there. And there we have it. Pineapple pizza is the best. And everybody will know. Okay, so now let's think a little bit more closely about what's happening with this for loop. If we wanted to change where it started, well, we just change the start here. If we wanted to change where it ended, we would change this endpoint. If we wanted to change the spacing, we would just change the increment number. And then we can also change, just like with a while loop, what value we have for x when we write our text. Great. One thing that can be confusing about a for loop is to remember what these semicolons do. You just need to remember that they always have to be there to separate the 3 parts. If we don't have them there, then we're going to get some weird error messages about our for loop, so whenever we see that, just double check that you have them. You also might get over-enthusiastic and add an extra one at the end. But if you just remember that semicolons are only there to separate the 3 parts, then we can say that, well, this last semicolon isn't separating anything, it's just kind of trailing on there. We can get rid of it because we don't need it. Now, I know you're probably getting a little bit tired of seeing these for loops getting converted into while loops and back, but let's just do it one more time, just so you can see that a for loop really is just another way to write a simple kind of a while loop, and you'll be really, really confident in understanding how to go from a for loop back into a while loop. Because you can do that, actually, with any kind of for loop, not just this one. The first thing that we do is think about where to put this first value that we have inside of our for loop. Well, since it's just initializing this variable, remember that has to go outside, not inside the while loop. And it should go before as well, because we need to be using it during our while loop. Then you think about, well, where should this condition go? That's pretty easy. You probably remember that usually the stopping condition, or the repeat until condition, needs to go inside here. We're going to say that while y is less than 313, we'll just keep going. Finally, the change. Well, we always put the change at the end of the while loop in the loops that we've seen, so we should go and do that here. Now, we just need to move this text call inside, and there we have it. We can just comment out this for loop and see that we made the exact same thing happen once more. So, hopefully by now you can see that this new for loop isn't actually necessary. We could go through our entire programming lives writing loops that looked like this. But it is a little bit impressive how much more concise this for loop is, and how it makes it a little bit more clear once you're used to it, what's going on with how we're starting a variable, we're saying how long to keep going, and then we're changing that variable here. So, if you really hate for loops, you don't have to use them ever, but you should be used to seeing them, and if they're confusing, just remember that you can convert them right back into a while loop like this. And if you're feeling adventurous, try using a for loop in your new program, or going back to some of your old simple while loops and converting them into for loops if appropriate. As a final note, you cannot always convert a while loop into a for loop, only when they're in a really simple form like this, where it's really clear what variable you're starting out, how long it's going for, and how it's changing.
Okay, we pretty much just um, like we just went for a new loop, which is for loops. But we can use either that or the while loop, which I'm thinking of using the for loop because it's like smaller. But I think it should be in this challenge a line paper. Let's see. Let's see. Convert to a for loop. Yep. Okay. I'm gonna mute my mic again, and yeah. Okay guys, we're gonna watch this video and then I'm gonna read over the review and then do the project. Hopefully I have enough time to do it.
A gem. Pretty sweet gem. But you know what's better than a single gem? Would be a whole row of gems. And of course, now we know the best way to make a row of gems would be with a loop. So let's use a for loop to draw 12 gems in a row, going from left to right across the screen. Woo, like that. So we say for var I equals 0, I is less than 12, I plus plus. And then we'll just take this line and move it inside here. Okay, so now we have 12 gems, but they're actually all piled right on top of each other. Remember, we want them going across the screen. So that means we want to be changing the x. And 36 is the x right now, but we want it to be different each time. That means we want it to be dependent on I. So what we can do is simply say I times 36. And so then the first one is at 0, and then 36, and then 72, and etc., etc. Cool, so now we have a row of gems. And this kind of reminds me of those scenes in Indiana Jones or Aladdin where the hero discovers that underground treasure trove of gems, but they usually find way more gems than this. They not just a row of gems, but a pile of gems. So how could we actually make gems going all the way down the screen too? Well, we could start by just repeating the for loop and copy pasting it and then changing this y each time. And so we'll change it 60 and then 90. Okay, so now we have 3 rows of gems, and that's cool. But this is also getting really boring because all I'm doing is copying and pasting and changing this one little thing. And normally in the past, when we found ourselves writing repetitive code like that, we would be like, oh, maybe we should just use a loop instead. But we're already using a loop. So what's the solution to avoid writing this, doing this repetitive copy paste? Well, it's something we call nested for loops, a loop within a loop. So what we're going to do is we're going to make an outer loop, and that's what's going to take care of going down the screen. And then our inner loop is going to keep taking care of what it's doing now, which is going from left to right. Let me show you what I mean. So for, and we'll use a different variable, j, since we're already using I. So for var j equals 0, and we'll say j is less than 13, and j plus plus. Okay, so that's going to be our outer loop. That's going to be in charge of going top to bottom. And then we're just going to take one of our previous for loops and put it inside there and fix the indenting. And we'll delete these old ones. Okay, so now what we have is we've got them all piled on top on the same row. So the thing is that we want to change the y, right? That's what we were changing before when we were copying and pasting, and right now the y is always 90. So we want the y to change for each row. So just the way that the x is dependent on I, we want the y to be dependent on j. So we can go ahead and change this to something like maybe j times 30. Ta-da! Yay! So many gems! Woo! All right, let's walk through what this does. Again, the outer loop creates this variable j and increments it up to 13. And in each execution of that outer loop, it runs this inner loop. And the inner loop creates the variable I and goes up to 12. And for each execution of the inner loop, it draws an image on the x and y, which are based off of I and j. And this I changes a lot more frequently than the j because of that. To try and understand this even better, let's try and actually visualize the I and j values. So what I'll do is I'll comment out image, and then set a fill color, and I'm going to use the text command to show the value of j. So text j, and then I'll put it at an appropriate spot here. Okay, so now we can see j going from 0 to 12, and this is basically where our rows of gems were positioned as well, right? And now let's visualize I and see how that changes. So for I, let's make it a different color. And then we'll go and put the I somewhere. and we'll change its X so that it goes across the screen, and we'll do the same thing for the Y. Okay, so now we can see that the I is going from 0 to 11, and that the I, as I was saying, it changes a lot more frequently, and this line of code gets executed a lot more times than this line of code, because this line of code is getting executed for every execution of this inner for loop, whereas this line of code only gets executed for every execution of the outer loop. So hopefully this, visualizing the I and J, hopefully that helps you understand what's going on with these nested for loops better. But now let's bring back our gems, because they're kind of cooler. Okay, so there's a lot you can do with nested for loops. If you just think about everything in the world that looks like a two-dimensional grid, like a chessboard, a quilt, the stars on the US flag, cool patterns and wallpapers. But to start off your imagination, just play around with this code, like by changing the image. I'll start off by changing it to a heart to show you how much I love nested for loops. Aww.
Okay, now we're going to review. After we review, we're going to do this project. So, JavaScript has two kinds of loops, the while loop and the for loop. We reviewed while loops as this, but the numbers being different and the variables being different. And then the infinite loop is, well, it's still the while loop, but the infinite while loop is without this y plus equals 20. It's just that. And then the for loop is just all that simplified in like 2 lines, which I don't know why, but it just showed, I don't know why, but it just showed a spin-off, because I never thought of doing like this, like a project like this. But yeah. So draw a window, then use a for loop to draw row windows. Draw a row of grass, maybe some bushes with flowers. The house is plain color right now. Use loops to make a brick house, or a house with sliding, or a log cabin. Check the images library for ways to make that more realistic. And then a bonus, use a conditional loop, a conditional inside a for loop to make more interesting grass and walls, using a different color for every other iteration of the loop. Hint, use the percent operator. What's a percent operator? But I mean, that bonus is probably for people who wants to do more stuff with this. But all the documentation's right here. I mean, there's not that much, as you can see, but there's a lot of information on this. Like it's like whenever you get a math paper, like a math paper, with the formulas on it. Like it's called a formula sheet. This documentation is just a formula sheet, but it's with code instead of math stuff. But there can be math in this, so hold on. So draw a window, then use a for loop. So a window, I think I might know what to do for this. Let's just put it down here. So rect, and then 20, 20, 20, 20, and boom, bang. That's a box. That's not a window. Let's change it to 40 over 40. Okay, and then let's change how this it's been, so it's that, and then so this is going to be fill, and then it's going to be like not white, but it's going to be black windows. But the but let's see, because I'm not. Use a for loop to draw a row of windows. I need I need to look over the review a little bit more. So fill rect. Wait, what? Wait, does it fill rect? Okay, so this is 2 backslashes, and this is windows, and then this is house, and then the up here is the sky. Oh wait, it's gonna be backslash sky. So now, okay, it's 8:28. I may not finish this, but I'll try. So review. So variable. So variable text y that y. So that's for text. But if we want a rect, then we can just use that other rect thing. But y plus equals 20. So how far we want it to go? Do we want it to go like 20? Let's copy. Let's paste it. But let's see. Do we want to change that to? Oh wait, not that. But do we want to change the 87 to a so that would probably be 158. Well, it could be 87 plus 40, so 87 plus 40. So okay, so 87 plus 40, not 40. Okay, that's okay, but 45. Nope, not 45. Let's do 60. 60 is good, so let's just make that go back. Wait, not that 87. Let's actually make this go back a little bit. Okay, so it's 81 and then 87 plus 60. So 81 plus 60. Okay, so that would be so for loop. Let's try and think of it as this. So there's variable var. Oh wait, let's actually let's just do this slash, and then let's take that to the bottom, and then slash that. Wait, nope, it's the other way. I forgot it's the other way to. So that's just now. Looks like you're missing that. Oh wait, yeah, var. Let's say win equals 81. Yeah, 81. Win 81. And then let's say, okay, let's so the for loop is var that Oh wait. Wait, why did I go back to nested? I mean, there's no like save button for this until I think the oh no's. God. Okay, so win must be greater than 60. I'm not sure, I'm just picking out random values. Let's see. I will see you guys later. I have to go, and we're going to review this tomorrow. Bye.